Hello, everyone. I'm your host, Cynthia Wins, welcoming you to another episode of SLB New Energy Conversations. Today, we're diving into the world of data centers, the digital backbone of our modern lives. From AI to cloud computing, data centers are growing at an exponential rate. But with that growth comes a new set of challenges: energy demand, water usage, carbon emissions, and infrastructure bottlenecks. In this episode, we'll explore how technology is being used to accelerate deployment, optimize performance, and decarbonize operations, all while keeping pace with the explosive demand for digital services. Joining us is Eddie Ganzanati, VP of Data Centers and New Energy Americas at SLB. He'll help us unpack the complexities and opportunities in this space. With deep expertise in engineering, power generation, and technologies, Eddie is at the forefront of helping industries rethink how we build, power, and optimize data centers for the future. Welcome, Eddie. We are thrilled to have you with us today.
No, thanks for having me. Looking forward to the conversation.
Absolutely. So let's just start with the big picture. What are some of the pressing challenges facing data centers today?
Yeah, with the massive amount of demand and growth in the industry, really powered by AI, power is the number one topic that everybody's talking about. The grids are stressed. There's a lot of infrastructure that needs to be added just to keep up with the level of demand. After that, I would say probably water, especially in some of the water scarce states, such as Nevada. You've got situations where really the primary way that data centers are cooled is through evaporative cooling, and it uses millions of gallons of water in some cases. And so this is definitely an issue that the industry is looking to solve. I would say after that, it's probably land. And really, for latency purposes, a lot of data centers want to be close to major metropolitan areas. Land isn't, ready and available everywhere, as well as the permitting associated with bringing those online. And then finally, infrastructure. Across the U.S. and really across the world, skilled labor isn't available everywhere. And so, stick building this stuff, bringing data centers online quicker. A lot of times there's delays and, issues with quality, consistency, and the like. So,
I guess now just AI and data centers. We see a rise of AI. How does AI impact the data center design,
mhm.
particularly when it comes to, say, training versus inference?
No, it's a good question. So, um, first, let's start with training. So, these are massive data centers. They're not necessarily interfacing with the user. They're building the algorithms that will ultimately, power the chat GPTs and the like of the world. And so they're running for days, weeks at a time, just doing massive amounts of computation to create these models. And so these are large operations with some of the most advanced GPUs, and they're typically gigawatt type scale, right? So massive amount of electricity that's utilized. The others on the inference side, once that model is built, then a user interfaces with it to get back the results that we see on something like a chat GPT. And so typically there you want quick response, so latency matters. And so demand is usually around a 60-mile radius of a major metropolitan area. And so again, like we said, that can be difficult with land availability and the like.
Yeah. And it sounds like the design implications are huge as well.
Yeah, no, from a design perspective, again, you have one, let's say, that's more focused on, really computation, large amounts of power. The other still uses a lot of power. It could be 100, 300 megawatt type facility, but really the focus there is on the speed and the response associated with the latency.
Right. So let's dig deeper into the cooling. Why is water such a critical issue with data centers?
Yeah, so today, I would say the majority of data centers are cooled, air cooled, and ultimately that heat is dissipated through an evaporative cooling system. And so water is used in that process, millions of gallons of it, to dissipate that heat. And so, this is difficult for especially, areas like Arizona, Nevada, and the like, where water is, a scarce resource. And so industry is working to solve this problem. And there's been some movement for data centers to move to a closed loop system where the water is recirculated and used over and over in that cooling process. But there's an efficiency trade-off. So if you think of the energy consumed per volume of compute, perhaps, in a, best case scenario for an air-cooled, evaporative cooling type solution, maybe it's a 1.1. In a closed loop system, that could go as high as a 1.5. So almost a 50% increase for the same volume of compute when you think of the energy that's required. And so constantly, site by site, we're working to balance the amount of.
So when you say 1-to-1 versus 1-to-5, explain to me 1-to-1, like what? Help me understand that a little better.
So just think of the amount of energy that is required per volume of compute.
Oh,
So
literally
so
1-to-1.
so
Sure.
if all of your energy was used for compute, it'd be a ratio of 1.
Wow.
Right? And so when you think of 1.1, that, a slight fraction of that is being used for the cooling, to where if it's 1.5, you have considerable amount more in terms of support systems, cooling, and the like that is required to facilitate that same volume of compute.
Wow. Well, so with these challenges, you work with many companies. How do you accelerate deployment of new data centers?
Yeah, so I would say one of the biggest trends and advancements that we've seen is really a modular approach, right? So historically, within the industry, a lot of the building is kind of done stick-built on location, like I said, utilizing skilled, qualified labor where available.
So clarify for me real quick. When you say stick built, to the lay user, what is stick built versus?
So think of it more piece by piece, all being bolted together to construct a facility and the components that go into it.
And doing that on site versus bringing in a structure that has been constructed. Got it.
And so, we see things where we're taking a modular approach, perhaps for server racks, cooling systems, power distribution, all being built in a climate-controlled environment where you can kind of maintain consistency, ensure the quality. And again, you can imagine once that's on location,
Right.
a lot less, technical expertise is required, and you can assemble this almost in a Lego-like fashion very quickly.
I like that analogy, Lego-like fashion. That makes perfect sense. Okay, once a data center is up and running, how do operators optimize performance and efficiency? I know optimization is a continuous process.
Yeah.
So I guess maybe your cooling techniques, your electrical distribution, the retrofitting. How do you optimize those things?
Yeah, so it's changing constantly. And so if you think of the chips that are out today and the amount of heat that they're generating, that next generation could be 6 times faster, right? And a considerable higher amount of heat that would be generated. And so the systems that are required have to be different, right? You've kind of reached the beyond the capabilities of something that's air cooled, and so now we're seeing advancements and focus on things like liquid cooling, as well as immersion cooling, direct to chip. And so, there's a lot of different terms, but ultimately, what the focus is: what are the different medias that can be used to dissipate heat quicker? Because the issue is, as these chips heat up, they degrade in performance, or perhaps break down. And so that optimization is constantly happening. And if you think of the data center itself, there's kind of a dynamic aspect to it, right? In terms of retrofit. So many co-locators and hyperscalers alike are looking at, okay, given the existing infrastructure that I have today, as this new technology comes online, how do I augment the guts, if you will, of the data center itself, right? And so many are taking a modular approach to that, but again, the pace at which these chips are being developed and the new variables that are coming into the equation, and it's not just heat. In some cases, it's the quality of the power. Um,
I was just going to ask, how do you mitigate or reduce losses? And I guess it's the power source itself.
Yeah, and so we're starting to see in some cases that slight variations in the quality of the power, even though it'll be filtered through a battery system like an APC, uh, doesn't get rid of all those variations, and so we're seeing degradations in performance. So now industry's looking at other ways, even outside of the fence line, to further clean and provide even higher quality power.
And then you achieve reliability once we achieve that higher quality power. Yeah, nice. And you briefly touched on how they would be sustainable. And let's talk about sustainability. Um, how are data centers working to decarbonize their operations?
Yeah, so the major players in the industry, the hyperscalers, have made commitments, carbon commitments publicly,
Mhm.
and so I would there's I would say a multi-pronged approach to this, both near term, midterm, and long term, right? And so in some cases, the focus has been on renewables, using power purchase agreements um, to basically show that the electricity that's being used is as clean as possible. In addition to that, there's gaps, right? And so some will also purchase carbon credits. So we and others work with industry, for example, like pulp and paper, um, to capture carbon during those processes and sequester it into the ground to create a credit. And then lastly, there's a focus more, I would say, in the near term towards bringing base load power online that is green. So perhaps geothermal. You could think midterm, long term. There's a lot of talk about nuclear. And so it's kind of the combination of these things that industry's working on to basically be able to meet those sustainability targets.
And clearly, no one can solve this alone. So, if we talk about collaboration in the industry, what kind of collaboration is needed to bring the big picture together?
Yeah. So there's a lot of different partners in this ecosystem, right? And so you can think of both at the local, federal, state level, a lot of collaboration within amongst governments. We hear a lot about different initiatives in the news, all the way up to the White House, and then also I would say even across borders when it comes when we look at country to country. So in some cases there's excess electrons in one country that could be utilized in another. So we're helping facilitate those types of moves to really help meet the demand that's out there.
So, what about industry partnerships?
Yeah. So within the industry, there's different, I would say, companies that are focused on different aspects, right? So again, from the OEM side of cooling through to electrical distribution, there's collaborations that are happening to figure out kind of what that next generation of technology will be to meet these ever-changing demands.
And how is SLB uniquely positioned to support this transformation?
Yeah. So what's great about SLB is we're a company of engineers and we love solving problems.
Yes.
And so I think as we've highlighted, it's an industry that's full of opportunity that needs solving. And we have deep domain expertise in you know, the electrical distribution side of things, thermal management and cooling, process engineering and optimization. And so really we're taking those resources and focusing them really to impact the way digital infrastructure evolves. And so it's exciting.
And that's so funny. That's my last question is what excites you most about the future of data centers, and where do you see the biggest opportunities ahead?
Yeah, no, no, thanks for that. No, when I think of, you know, the ex what excites me, it's really you think of really there's 2 main things going on that, really are shaping, our existence today. So, one, you have a digital transformation that's
Mhm.
happening around AI, and that's I think we're starting to see the impact that may have, on all of our lives and businesses alike. And then you also have an energy transition, right? And so to be at kind of the forefront of both of those and seeing how they come together to really reshape the way the world works is super exciting. And in terms of kind of what inspires me, it's the problems, right? And so the problems we're solving today didn't exist 5 years ago,
Mm.
and the problems that we are going to solve tomorrow don't we don't even know exactly what they'll be as we sit here today. And so when I think about the opportunity to collaborate with industry, work with different governments, really help scale and impact the future to create something that's smarter, cleaner, and more connected. It's exciting.
It is exciting, and I hear you reimagining the infrastructure, global collaboration, sustainable innovation, and we're so thankful to have you at the forefront of it all. Thank you so much for your insights, Eddie. What a pleasure to have you with us today.
Thank you.
And thank all of you for listening to this episode of SLB New Energy Conversations. Be sure to follow us to hear more from SLB's diverse team of changemakers and experts in energy transition. See you next time.